Hello guys, let's work on 5.2. What you're seeing on the screen right now is a bunch of letters, and they are from the Greek alphabet system. And I just thought it might be good to have a little bit of background about the Greek alphabet because we are going to be seeing quite a few of these symbols showing up, especially the alpha symbol, lowercase alpha. We will definitely be working with theta and those two in particular. You'll see some of the others. You already know pi, lowercase pi is one that you've worked with, but just thought might be interesting. And that was our homework from night 4. Take a look at these numbers, 3, 4, and 5. What's so special about 3, 4, and 5? Or what about 6, 8, and 10, 12, 16, and 20? Well, what these numbers have in common is that they are Pythagorean triples. If you think about the Pythagorean theorem, these are, oops, let's write triples, right? These are numbers that work perfectly in the Pythagorean theorem. So if I took 5 squared plus 12 squared, I would get 13 squared. If I took 7 squared plus 24 squared, I would equal 25 squared. You can see how some of these are derivatives off of the 3, 4, 5 triangle. So if I increased and multiplied everything by 4, 3 times 4 give me 12, 4 times 4 is 16, and 5 times 4 is 20. So Pythagorean triples, good to know. Have a few of them in your back pocket. Let's skip that. 5.2, working with trigonometric ratios in a right triangle. Some of these you'll be very familiar with, a little background information. Right triangles, all based on this idea that we have similar triangles. If I pop this in here, you can see how the angles all do match up. And if I have angle-angle congruent, I have similar triangles, angle-angle similarity from geometry. So the trig ratios are all based off this idea that any particular triangle may be similar to others, and they maintain the same ratios. In the parts of a right triangle, we know we've got the right angle, and across from it is, of course, the hypotenuse. We can come in with 2 little acute angles for the other 2 angles, and then the legs that are attached to the right angles are called legs, the sides. Just a note, if you would take a look at your graphing calculator and make sure that you are set in degree mode right now. And you will do that through the mode button, which is on the upper row of your graphing calculator. So let's just run through. You should know these trigonometric functions already. So for sine, we shorten sine to just sin. It's not pronounced sin, it is sine. And here I'm using the Greek letter theta for our variable. And the sine of theta is defined as the opposite side compared to the hypotenuse. Something that you are probably well aware of. So the sine of theta equals opposite side compared to the hypotenuse. Where is the opposite side? Well, if this is my angle, then opposite it looks like that. And hypotenuse is easy to find. It is opposite the right angle, always our longest side. And then the adjacent side would be the leg that is right attached with my angle that I'm talking about. Cosine, of course, abbreviated COS of theta. And that compares the adjacent side to the hypotenuse. And the tangent, abbreviated tan, tan of some angle is equal to the opposite side compared to the adjacent side. If you remember, probably back algebra or to geometry, SOHCAHTOA, a quick way to remember those relationships. What you haven't had, though, are the reciprocal trig functions. And there are 3 more trig functions that you have probably never been exposed to. One is abbreviated CSC. It stands for cosecant. SEC stands for secant. and COT stands for cotangent. The cosecant is equal to 1 over the sine of theta. And if I tip over sine, I would have the hypotenuse compared to the opposite side. They are reciprocal, so they do get tipped over. The secant is similar and related to the cosine. So it is the reciprocal of cosine, or 1 over cosine, which means that I'm going to have the hypotenuse on top, and it will get compared to the adjacent side. And finally, cotan is 1 over the tangent of that same angle. And I would have, usually it's opposite over adjacent, so this is going to be adjacent over the opposite side. Good enough, those three. So purely definitions. Easy way to remember which ones go together. They're kind of like the perfect co-pairings. So Skippy peanut butter and Smucker's jam peanut butter and jelly are like sine and cosine, or cosecant. Cosine matches up with secant. And milk and cookies, that's like tangent and cotangent. What you'll notice, an easy way to remember this, is there is only ever one cosine in with any one pairing, or I shouldn't say cosine, any one co-pairing within any partnership. So cosine and secant go together, cosecant and sine go together, cotan and tan go together. You never should have a pairing where you say cosine and cosecant. They don't match up with the two cos together. Finding values of sine, cosine, and tangent, we will incorporate the Pythagorean theorem on this. So a squared plus b squared equals c squared. Recall that that is a leg being squared plus another leg being squared, and that will equal our hypotenuse squared. That's what the letters A, B, and C stand for. So I have 9, I have 24. What I don't know is that guy. So let's find him. One leg plus the other leg, I'm going to simply call this one x, will equal 24 squared. 9 squared is 81, x squared. 24 squared, I think, is 576. And if we subtract our 81, we will have 495. So x squared is equal to 495. Therefore, x is equal to the square root of 495. And I suppose we should reduce that down. I pause for a moment. 495 could be thought of as 9 times 55, and that means this is going to be a 3 root 55. So my side up here, I have just found, is 3 root 55. Now, the work that we want to do is to find all of the three basic ones, the sine, the cosine, and the tangent of them. So the sine from angle L, so the sine of L is equal to opposite, which is 9, and hypotenuse is 24. I knew that this was my angle over here. Think of yourself as, kind of an eye viewing this. Opposite my position at L would be the 9 and hypotenuse of 24. Cosine of L, cosine means I'm comparing the adjacent side, so a 3 square root 55 over 24, which can reduce to square root 55 over 8, because we all know 3 goes into 24 8 times. And finally, the tangent from angle L compares the opposite side to the adjacent side. So that means I'm comparing 9 over square root of 355. I'm sorry, square root of 3 square root 55, and reducing down 3 goes into 3 once and into 9. And then I'm left with the radical on the bottom, which I shouldn't leave my answer with a radical, so I'm going to do the quick rationalizing step, and I will get 3 root 55 over 55 as my answer. So a little bit of work on that. Number 2, cosine of 2/9, and they want us to find the secant. Well, the secant pairs up with cosine, and it is its reciprocal. So I know the cosine of theta is 2 over 9, which compares the adjacent side to the hypotenuse. And if I want to find secant of theta, then I'm going to compare the hypotenuse over the adjacent. So basically, I just have to take the reciprocal of my cosine, and I can come up with secant 9/2. This one says sine of theta equals 0.525, and they want us to find the cosecant. Well, sine of theta and cosecant of theta are reciprocals. So I can say if I know sine is equal to 525, then cosecant is the reciprocal of that. That was like 0.525 over 1, so now I have 1 over 0.525, and quickly do the math on that. 1 divided by 0.525 comes out with 1.905. Since they went to thousands, I'm going to go to thousands. Number 4, find all values for the 6 trigonometric functions and express those. So calculate the hypotenuse on this one. 70 squared plus 24 squared will equal my hypotenuse squared, which I'm just going to refer to it as C. And 70 squared plus 24 squared all right, quickly I did 70 squared, got 4,900, and then I did 576 was 24 squared. Add them together and I got 5,476 equals C squared. So C will be the square root of 5476, and that turns out to be a nice number of 74. Now walking through the 3 trig functions, or the 6 trig functions, sine compares opposite to hypotenuse. Remember your so, ka, to a bit. So I need opposite side from theta. Opposite theta is our 70. It gets compared to the hypotenuse of 74, and then reduce that down. Take a moment and do that. Adjacent compared to hypotenuse. Adjacent side is right next to my theta, and that would be 24 compared to 74, and reduce that down. Take a moment and do that. Tangent compares opposite to adjacent. That's our TOA, over A. Opposite 70, adjacent 24, and reduce your fraction there. What would that be, like 35/12 divided by 2s? Sine matches up with cosecant. The cosecant of theta is going to be just the reciprocal, 74 70ths. If I divide by 2, I'm going to have 37 35ths. And cosine matches up with secant, and that is going to compare hypotenuse over adjacent. Hypotenuse of 74, adjacent side of 24, reduces down to 37/12. And tangent, cotangent is its reciprocal function, and that is going to compare. Normally it's opposite over adjacent, so this is going to be adjacent over opposite. And my adjacent side is 24, my opposite is 70. How about 12/35? See if you can do number 5, and we'll pick up in class with number 5. There is a short quiz that you can take after this, so flip over to quiz and do that. Answer those 5 short questions.